Okay, let us start today's discussion. I hope I am audible. Today, we will start the discussion with joint and conditional probability. Okay, and then we will solve some numerical problems. So let us start. First thing is joint probability. Okay. Okay, so we are discussing joint probability. What is joint probability? If there is a sample space and it consists two events, A and B. Let us consider event A and B. Am I audible?
Yes, sir.
There is two event A and event B, and these are mutually exclusive. Okay, and these are exclusive. So how will it look like if this is the entire space S, let us assume, and this is event A and this is event B. So if event A and B are mutually exclusive, so it will look like this. Now, what is the joint probability? Joint probability is the probability of these two events occurring jointly or simultaneously. Okay. So if two events A and B are mutually exclusive and these are occurring jointly, then the probability of these two events are called joint probability. Okay. So if there is an experiment and it is repeated n times, and the joint occurrence of event A and B is, let us take an experiment. Is repeated n times. Okay. And the joint occurrence of A and B. This is one thing. Another thing is joint occurrence of A and B is n of AB. Then what will be the joint probability? So the joint probability of A and B is, we can define it as probability of like this, right? A intersection B, and it will be limit n tends to infinity n of AB upon n. So this is the joint probability. Okay. Now from last week's discussion, we know that probability of A intersection B is equal to probability of A plus probability of B minus probability of A union B. Is it clear till now? Any doubt? Okay. Now, if we are saying that A and B are mutually exclusive, then probability of A intersection B will be 0, right? Okay, we will come in here later. Let us first consider that probability of A union B is what? From here, this line, we can get probability of A plus probability of B minus probability of A intersection B. Fine. Now, if probability of A intersection B is not is equal to 0, then what will happen? Then we can say that probability of A union B is less than or is equal to probability of A plus probability of B. Fine. This is an important formula to be remembered for joint probability. Now, continuing this concept, we will go to conditional probability, right? So let us start first conditional probability, then we will start solving some numerical problems to understand it in better way. So now, what is conditional probability? Suppose there is two events. Events A and B. Okay. A is happening n of A times and B is occurring n of B times, and jointly A and B are occurring n of AB times. Okay. Now the question is, what is conditional probability? The conditional probability of event A given event B. If we are saying that the conditional probability of event A given event B, it is the relative frequency of joint occurrence AB with respect to event B. What it means? It means limit n tends to infinity n of AB by divided by n of B with a specific condition. What is that condition? N of B should be greater than 0. Okay. Now we can write it in this way also. Limit n tends to infinity n of AB by n n of B by divided by n. Fine. Now is it not the same thing? We have already written that n of AB divided by n, this is probability of A intersection B, right? Probability of A intersection B, and n of B by n, what is it? It is probability of B. So this is the conditional probability of A upon B. Similarly, we can say probability of B upon A or B conditioned on A will be A intersection B divided by probability of A, conditioned on that probability of A not is equal to 0. Fine. Any questions till now? No questions. Okay. So from conditional probability, we can write that joint probability of A upon B, joint probability of A and B is equal to conditional probability of A upon B into probability B of B, which is same as probability conditional probability of B upon A multiplied by probability of A. Fine. So let us take an example. It is very simple example. That probability of a student will get marks between 70 and 80 is that a student between 70 to 80. is 0.154. Okay. It is known that probability of getting marks greater than 70 is 0.6. So this two thing is given, and what is given? That what we need to calculate. We have to calculate the joint we have to calculate that the conditional probability of a student of getting marks between 70 to 80 conditional on that the marks is greater than 70. So if this is probability of A intersection B and this is probability of B, then we will get the probability of marks between 70 to 80 assuming that the probability or given that marks is greater than 70, is simple probability of A intersection B by probability of B. So it will be 0.154 upon 0.6, which will be around 0.256. Okay, it will be more clear in the next few examples. Let us take another example. Example 2. For any two event, A and B in a sample space S. Okay, if B is in the sample space A or B is the subset of A, then what will be the probability of A conditioned on B? This is the question. So let us try to solve this. There is a sample space S. There is two events, A and B is the complete subset of A. Okay. Now the condition is, the question is, what will be the probability of A under the condition of B? So from the formula we can write probability of A intersection B by probability of B. This is clear?
Yes, sir.
Okay, so can you tell that in this case, if this is the scenario, that this is the sample space S, this is a event A and event B, and B is the complete subset of A, then what will be the probability of A intersection B? Just think about it, take 2-3 minutes. Yes?
Set B.
Set B, yes, fine. Not set B exactly. You are partially right that if this is the condition, then A intersection B will be set B. But if we are saying probability of A intersection B, then it will be probability of B, right? So you can simply write it probability of B divided by probability of B, which is 1. So we are getting probability of A under the condition of probability B is 1. And can you think it intuitively? Mathematically it is coming 1, but can we realize the whole thing intuitively, that if we are saying that what is the conditional probability of A upon B, what it signifies? It signifies that if B is occurring, then what is the probability that then A is also occurring? Is it?
Yes.
Okay. So from this figure, we can easily say that if B is occurring, then it is obvious that A is also occurring. So the probability is 100% that if B is occurring, then probability of occurrence of A is 100%. So clearly it will be 1. So intuitively also we can say like this, right? Now there's someone else. Now let us come to another example. Example 2. Sorry, example 3. If the whole thing is same, this is set sample space S, this is A, and this is the set B, event B, and event B is the subset of event A. The whole scenario is same, event B is a subset of event A. Then what is the probability of B under the condition of A? Can you solve this? Take 2-3 minutes and try to solve, or at least try to think. The earlier or the previous example was that A and B are two events in the sample space S, and it is given that event B is a subset, or more clearly we can say it's the complete subset of A. So this is the figure, and the condition question is what is the probability of A conditioned upon B. So we got the answer 1. Now the same question is B is the complete subset of A, and question is what is the conditional probability of B upon A. Earlier it was A upon B. Try to think.
Sir, can you please repeat this part? I didn't hear.
Okay. uh, Come to example 2 first. In example 2 we noticed that there is a sample space S, there are two events A and B. So the event B is a complete subset of event A. So what is the conditional probability of A upon B? So we got the answer 1. Now same thing is happening again. B is the complete subset of A. This is the figure. So what is the conditional probability of B upon A? Just the reverse of this.
So there is also
Let it,
a one. Sorry.
no. Let us try to solve. Probability of B upon A. What is the formula? A intersection B upon probability of A. And we have already noticed that probability of A intersection B is probability of B. So this is probability of B and this is probability of A. Is it fine?
Yes, sir.
Okay. So now there is no specific value. Why? Now the question is why there is no specific value. So again, can we realize the thing intuitively? rather than mathematically? Look, earlier we were telling that condition that probably what is the probability of A if probability of B is occurring, right? So from this diagram we can easily say that if B is happening, then obviously A is also happening because B is complete subset of A. Now we are saying that A is happening. What is the condition that B is also happening? So look, let us take a event here. This is a event. Then what is mean that it is a event in B. So event B is happening and event A is also happening. But if some element is here, so can we say that both is happening? Not, here A is happening but B is not happening. So this is the intuitive idea or intuitive approach, that if this is the condition, there may be some events that is included in event A only but not in B. So we cannot say that if A is happening, what is the condition of probability B? So this is the value. There is no such clear answer or any numerical value without any further information. Okay. Now let us take a very interesting example. Example 4. If there is any doubt, please write in the chat box. Okay. We are saying again that two events are occurring, A and B, and we need to find probability of A under the condition of B. And what is the value of this? If there is few exam options, that it is 0.5 or minus 0.5, let us take minus 0.2 or 0.2. There are four options, and we are saying that what could be possible answer? Can you say? Please try to answer. Think 2-3 minutes you take. The question is, two events are occurring like all other the previous questions, A and B, and we are saying that what is the conditional probability of A upon B? There is four options: 0.5 minus 0.5 minus 0.2 and 0.2. What could be possible solution or possible answer among these four options?
Sir, may 0.5 or 0.2?
Zero, you are saying 0.5 and 0.2. So these two will not be there.
No,
Minus
sir.
0.5.
Only take the positive values between 0 and 1.
Yes. Yes, right. So why these two will not come? Let us see this, the proof of this. we can say that probability of A upon B is probability of A intersection B. Sometimes in few books, the probability of A intersection B may be written as probability of AB. So don't get confused between those two things. Divided by probability of B. Okay. And we know that probability of A intersection B is always positive, some positive value, and probability of B is always some positive value. So probability of A intersection B will also be positive value including 0, right? Positive value or 0, positive value or 0. So it will be positive value or 0. Basically it will be non-negative. Okay. Now there are few examples related to earlier example, this one and this one. So let us take again. There are two events. Okay, it is example 5. One thing that whatever we are discussing here, you need to solve some problems by your own also. Take any book, whatever you like, or you have access, any probability book or any book of stochastic process, whatever, you will find so many problems there. There may be some examples, solved examples, there may be some exercise also, and try to solve this. Okay, until and unless you solve by your own, the especially in this topic, probability and statistics, uh, up to now whatever is discussed you may find easy, but with the time being we will go in some more deeper concept like PDF, CDF and all, and so many things are there. So if we do not practice the things, you will forget, and you will not be able to get engaged in this all the things. Okay, so let us take example 5. Again, event A and event B is there. There is a sample space S. Now our condition is that sorry, A belongs to S. S is the sample space, and B belongs to S. Okay. Now the question is, question 1, what is the value of probability of A intersection S? Can anyone tell?
The probability of A.
So you are saying it is probability of A. Very good. How it is coming? Let us see using the figure. This is the sample space S. Let us take this is event A, and let us take this is event B. It may be in different way also, as there is nothing mentioned the relation between A and B, whether they are mutually exclusive or not, or whatever. So we are assuming it like this. So if A is a event in the sample space S, then it is clear that A intersection S is A itself. So probability of A intersection S will be probability of A. And the similar question in question 2. What is the probability of B intersection S? It will be probability B. In the same way, fine. Now there is another question, and it is similar to the earlier question also. Question is, if we say what is the probability of A under the condition of, sorry, probability of S under the condition of probability of A. Can anyone tell what will be the answer?
Sir, 1.
1. Right. It is same as the previous question. It is probability of A intersection S upon probability of A. And as we have already discussed, that probability of A intersection is probability of A. So probability of A upon probability of A is nothing but 1. Okay. So let us come in another example, example 6. There are 3 students in today's discussion. I think Puskor and Ummoy, you two are new, right? Have you attend any other discussion?
No, sir.
And Puskor?
No, no.
Okay, so you both are in which course?
Statistics honors.
Okay, and Puskor?
Probability course.
No, no. In which, graduation or masters or?
Okay, masters.
Okay, which? What is your department?
Electrical.
Electrical. Okay, great. In which college you are doing?
I'm in Trichy, United Trichy.
Okay, United TG. Good. And Ummoy?
Maulana Azad College.
Okay, okay. So let us take example 6. The question is, it is little bit tricky question, you can say, but not difficult. There are 2 events. Event A and event B. Okay. Now it is mentioned that these are mutually exclusive. Okay, mutually exclusive. Now what will be the joint event? Joint event of A intersection C and B intersection C. If event A and B are mutually exclusive event, then what is the nature of joint event of A intersection C and B intersection C, where C is any event? Try to think it intuitively first. You take 1-2 minutes and try to think that if A and B are mutually exclusive, then what we can propose regarding the joint event of probability of A intersection C and B intersection C. Try to think. Anyone can answer? The question is there are two events A and B which are mutually exclusive, and now what we can propose regarding the joint event of A intersection C and B intersection C, where C is any other event. Can we say that these two are also mutually exclusive? Can you say this? Or these are not mutually exclusive? So let us try to find the solution. If this is the sample space S, okay, there are two events, event A and event B, which are mutually exclusive. So we can draw it like this. Now there is any two event, or sorry, any other event C. Let us, this is C. This is possible region of C. So from here, what will be A intersection C? This portion. B intersection C will be this portion. So from here we can see that A intersection B and B intersection C is also mutually exclusive. So you understand, or any doubt is here? If there is any doubt, you can say.
Sir, repeat once.
Okay. Look, we are saying that A and B are mutually exclusive. What it means? We can draw it like this. This is event A, this is event B. Now, there is any other event C. So, I'm drawing it like this, that this is C. So, what will be A intersection C? The common area of A and C. This. What will be B intersection C? The common area between B and C. So this, there is no common area between A intersection C and B intersection C. Obviously there will not be, because these two are mutually exclusive. So these two areas are also mutually exclusive. In another way, let us take 2-3 type of figures. Then you will understand in more detail. Let this is A, this is B, and this is C. So this region will be A intersection C. This region will be B intersection C. So is there any common region between A intersection C and B intersection C? Is there?
Sir.
No. So if there is no common area of A intersection C and B intersection C, then these two events are also mutually exclusive. Now, if we say that this C event is any other event, so why it is like this only? So, okay, so if this is A, this is S, this is A, and this is B, there will be no common area between A and B because these are mutually exclusive, it is given. And let us assume that this is C. So A intersection C and B intersection C, what will be the value? A null matrix or null set, because there is no common area between A and C and B and C. If this is, then also A intersection B and A intersection C and B intersection C will be mutually exclusive. You understand? Now, from here, another question is, if we try to find probability of A union B under the condition of C, then what will be the answer? Question is same. A and B are two events, mutually exclusive event, and now we need to find probability of A union B under the condition of C. So what is probability of X under the condition Y? It is probability of X intersection Y upon probability of Y. This is clear. This is coming from here. any probability of A upon B is equal to probability of A intersection B by probability of B. So here we can write that it is probability of A union B intersection C divided by probability of C. Can we write this?
Yes, sir.
Okay, fine. Now, so our first task is what will be probability of A union B intersection C. This is our first task. Okay, let us not find the probability first. Let us find what is probability of A union B intersection C. It is nothing but A intersection C union B intersection C. This is clear.
Yes, sir.
Okay, so sorry, probability of A union B intersection C will be simply probability of A intersection C union probability of B intersection C. Fine. So we can write probability of A union B intersection upon C is equal to, from this we will replace this by this, probability of A intersection C union probability of B intersection C divided by probability of C. Okay, so can we write it like this? If we are saying that probability that two events A and B are mutually exclusive, so we have proved that if A and B are mutually exclusive, so A intersection C and B intersection C will also be mutually exclusive. So we can write this union by simple sum plus probability of B intersection C by probability of C. Till now, is it clear?
Yes,
Or
sir.
there is any confusion?
No,
Any
sir. Was clear.
confusion or anything to be repeated, you can say. Everyone? Okay. If there is nothing to be repeated, then let us continue. So it will be probability of A intersection C divided by probability of C plus probability of B intersection C divided by probability of C. So we can write it probability of A under the condition of C simply from this formula only. Probability of B under the condition C. Fine. So this is the value that if A and B are mutually exclusive, then probability of A union B under the condition of C will be this. Okay, it is clear to everyone. Now we will go to the next example, example 7. Prove that probability of A under the condition of probability of B is greater than probability of A. This we need to prove. Let us try to prove this. So probability of A under the condition of B. What is the value of this? Probability of A intersection B upon probability of B. Okay. Now, okay. So now the thing is, okay, this is not to be proved. The question is little different. Probability of B given A is greater than probability of B. This is to be proved. Given that probability of A upon B is greater than probability of A. This is given. And we need to prove this. Okay. So from here, from the definition, we can write like this. And it is given then that this is greater than probability of A. Now we will come to this. B given A, it will be A intersection B divided by probability of A. Now again come to this equation. From here, can we say that probability of A intersection B is greater than probability of A multiplied by probability of B? If this is true, then if we replace this by this inequality, then we can say that this is probability of is greater than probability of A multiplied by probability of B divided by probability of A, which is equal to probability of B. So what we are getting, probability of B under the condition of A is greater than probability of B. This was needed to be proved. Given this, is it clear or any doubt is there? Anyone, is there any doubt?
Very clear.
Yes. Uh, can you please tell again?
So this is clear.
Okay, this is clear. Okay, then we'll go to next topic, and that is total probability theorem. First, we will look at theoretical thing, then we'll solve some numerical problem. Total probability theorem. What is total probability theorem? So again, there is a sample space S. Okay, and there are n mutually exclusive events. There are some events Bn where n is equal to 1 to up to capital N. Okay, so there are events B1, B2 up to B capital N. So we are writing it as B small n. Okay, and the thing is that these all are mutually exclusive. It means Bm intersection Bn is a null set. for m not is equal to n. Is this line clear?
Yes, sir.
Okay. So now, what the total probability theorem says? It says that the probability of any event A defined on the sample space S can be expressed in terms of the conditional probabilities of the events Bn. If this is a sample space and here n number of elements are there, sorry, n number of events are there, which are mutually exclusive, then probability of A can be characterized by the conditional probability of event Bn. How? Let us try to see first, and then we will go in mathematical formulation of this. This is sample space S, this complete space. Okay. Now let us divide it. How? These are different events. Let us name B1, B2, B3, B4, B5, B6. This is B7, B8, and this is B9. So the whole thing was the sample space. These are different events. Now let us take an event like this, and this is A. Okay. To define it, let us draw in some. You try to look. Excuse me for Please wait for 2-3 minutes just until till now. Please you try to understand this. Sorry for the interruption. There was some urgency in between. Okay, so let us start where we have ended. Okay, so what is the total probability theorem? If this is the sample space S and these are different events from B1 to B9 and this is event A, so we can write the event A or probability of event A rather in terms of probability of A under the condition of Bn multiplied by probability of Bn, where n is equal to 1 to capital N. Here capital N is equal to 9. So what it indicates, this is the mathematical expression. So can we say that it is nothing but the probability of A under the condition of B1 into probability of B1 plus probability of A under the condition of B2 into probability of B2 plus up to A under the condition of B capital N into probability of B capital N. Okay, this is fine. Anyone?
Sir, please once repeat.
Yes. Look, this is sample space S. This is the event A, and we break the sample space S in different events B n, where n is equal to 1 to n. So B1, B2, B3 up to Bn, we are breaking it. So if we assimilate all the B1 to Bn event, B9 events, then we will get S. And now we are defining probability of A in terms of the conditional probability of A upon Bn. So the expression will be this. So how it is coming, that we are discussing now. Can we say that probability of, this is B1, A upon B1 into probability of B1 is nothing but probability of A intersection B1. Can we say this? Similarly, this is probability of A intersection B2. And at last, it is probability of A intersection Bn. Is this line clear from this line to this line, or there is any doubt? If there is any doubt, please say. Then I will repeat it again.
Yes, sir, all clear.
Okay, fine. So now look at this image. If what is probability of A intersection B1? This is A, this is B1. So this part we will get what will be A intersection B2. This part A intersection B3. This part A intersection B4 we will get this. A intersection B5 we will get this. And for B6 to B9 there is nothing. So this is proved in such way. Now we will come to another thing. What is that? That is Bayes theorem. This is Bayes theorem. Okay, so let's discuss Bayes theorem. It is coming from the total probability theorem also. So we need the concept of total probability theorem to understand the Bayes theorem. Okay. What is Bayes theorem? It states that if there is a sample space n and n number of mutually exclusive events, then any event A is defined on the sample space, then the condition of Bn upon A we can write using the Bayes theorem. There is sample space n, sorry, S. This is sample space S, and there are Bn number of n number of events Bn, where n is equal to 1 to up to capital N. Fine. And these all are mutually exclusive. Okay. Now we are saying there is another event A. So this is like this only. Please wait again 2-3 minutes. Hello. So there is
Yes,
some
sir.
little bit urgency, so we need to stop it here today.
Okay, sir.
Okay, sir.
Next week
Sir,
we will start. Yes, yes,
sir, can you send this notes?
yes. Notes will be uploaded. You have the link, right?
Yes,
And in that link, notes are updated every week.
but sir, I didn't get that.
Mm, I think from NPTEL itself you will get the link. Okay, fine. Can you write your mail IDs now in the chat box quickly,
Okay, sir.
or rather, you send me mail in this mail ID. Okay, I will share the link. And next day we will take some extra discussion. Today it is 20 minutes less, so we will cover that in next day. Okay.
Okay, sir.